Yes, shall I continue? Shall I continue?
Yes, sir.
Okay. When I draw the sketch, will come to know time being will understand it. See, what you should understand is, I have find it sigma n and sigma t. My ultimate goal is to find the maximum value of sigma n and minimum value of sigma n. This maximum value of sigma n in the sense, this is normal stress. N indicates this is the normal stress. Sigma t in the sense, T indicates tangential stress or shear stress. I want to find the maximum value of normal stress. The maximum value of normal stress in the sense, there is a maximum, give me a moment. Maximum value of normal stress in the sense, uh, as we have discussed this, these are the planes in which on which shear stresses are zero and the normal stresses are maximum. These are called as principal planes, and the stresses on these planes are called as principal stress. Since this case is very simple, I have found out that the maximum value of sigma n can be sigma n itself is equal to sigma 1, which is equal to sigma x. Minimum value can be equal to 0. Isn't it? The maximum value can be equal to sigma n is equal to sigma x. Minimum value is equal to 0. This just by inspection we have found it. Okay. Similarly, I can find the maximum value of shear stress by substituting 2 theta is equal to 90. I can forget this sin 2 theta sin becomes 1, and the maximum or minimum value, the magnitude remaining the same, is equal to sigma x by 2 and minus sigma x by 2, which we have found it out. Okay. Now, what is the purpose of finding it? It is, see, if I say, see, I have applied only normal stress. How the material can fail? See that our material is having a strength of only half of the normal stress. Half of the normal stress. If I load a ductile material in tension, it will fail within the load for a load of half of the normal stress, sigma x by 2. Okay, whereas it can withstand a load of sigma x, but it will not, we cannot go up to that load, it will fail half of the normal strength. So if you define the yield strength as 220 MPa at 250 MPa, then the shear stress is half of that. For example, for 110 MPa itself, my ductile material will fail due to shear. Okay, keeping that in mind. So you should know that, always you should remember that when I say sigma t, this is sigma t. I have obtained the maximum value of sigma t. Give me a moment. the uh, the maximum value of this is theta is equal to t. See, always you should remember that when I talk about principal planes, there are two principal planes and each are separated by 90, each are 90 degree apart. Similarly, there are shear stress planes, each are 90 degree apart. Okay, now keeping this in mind, always you should remember 2 points. Always you should remember 2 points. One is, when it's talk about principal stresses, principal stresses, these are the maximum normal stresses. These are the maximum normal stresses. I have found it the principal stresses. Okay. The principal stress magnitude is sigma 1 is equal to sigma x and sigma 2 is equal to 0. I will represent it later. Okay. Now, sir, you said that principal stresses are the maximum normal stresses. Let us substitute this. How can you say that there is no shear stresses induced? Let us take an expression for sigma t. On this plane, on the plane GE, whether there is shear stress at this plane, at an angle of theta is equal to 0 and theta is equal to 90 degree, we will find. We'll take sigma t is equal to minus sigma x into sine 2 theta by 2. Okay. At theta is equal to, at this angle, at theta is equal to, this is 0. Theta is equal to 0 and 90. At theta 1 is equal to theta 1 p, if you write, at theta p1 is equal to, at theta, I'll write theta, well, this is nothing but theta 1 p is equal to 0. Theta 2 p is equal to 90 degree. Sigma t is equal to minus sigma x into sine 0 is equal to 0. At theta 2, sine 2 theta is 180 degree, once again 0. So we can, this is the inference. So we can say that on the planes of maximum principal, on the planes of maximum stress, normal stress, also called as principal stress, there is no tangential stress acting, that is equal to 0. You can say sigma t is equal to 0, sigma t is equal to 0. Okay, but you should always remember that. When I talk about shear stresses, the maximum value obtained like this for inertial loading is better. But there is also, for this shear stresses, there is also normal stresses induced. Let us find. I have found out the shear stresses. Now let us go and calculate. A theta is equal, theta S1 is equal to. I will indicate the shear stress plane as S1 and S2. Principal stress plane as P1, P or P1 or P2 or P2 or something like this. With P suffix, I will indicate. With this, for this S1, S2, let me call this as theta P1, theta P2. Okay. Now, sir, you have said that on the principal planes there is no shear stress. We have proved that. Sir, now you prove that these are the maximum shear stress planes. On this plane, the shear stresses are maximum. Sir, you prove that on the shear stress planes there is no normal stresses. No, that is not the case. As we discussed on the shear stress plane, there can be normal stresses can also be induced. We'll clarify. We'll check that. Theta S1 sigma n. Let me write the expression for sigma n. Sigma n is equal to sigma x cos square theta. Sigma n is equal to sigma x cos square theta, and theta s1 is equal to 45 degree and 135 degree. Theta s1 equal to 45 degree. Theta s2 is equal to 135 degree. Okay. Therefore, if I substitute sigma n, I will get sigma n is equal to sigma x cos square theta, which is equal to half sigma n, which is equal to sigma x by 2. Similarly, sigma n at 125 degree is also 90 plus 45, which is nothing but sigma x by 2. On the planes, this sigma n, I will call it as sigma average. On the planes of maximum shear stress, we don't have the normal stress is equal to 0. We have the stress is equal to half of the normal stress. But on the planes of maximum normal stress, we have shear stress is equal to 0. Okay, that you should remember. Now, let us represent in terms of sketches. I will call this as principal stress. For given this plane, this is xy plane. If I write like this, x, this is y, this is xy plane, this is xy plane, this is xy plane. I want the stresses at this plane at an angle theta. Anti-clockwise angle is positive. I will discuss this later. But at an angle theta, I want on this plane GE. What are the principal stresses? What are the maximum stresses? I want to know. First, I will indicate xy plane like this. X, y. At what angle is my principal stress? My anti-clockwise measurement is positive. At theta is equal to 0, I have sigma 1. That is a sigma. I have sigma 1. This sigma n is equal to sigma 1. I will indicate. I will indicate. At theta is equal to 0, I have sigma 1. Okay. Next, I should indicate its respect to a plane like this. As soon as I write, I should indicate with respect, I should write xy plane and I should indicate a plane like this. For this plane, I take for this plane. For this plane, if the theta is some angle, I could have represented it. When I come to shear stress or indicator, I should write a plane at sigma 1. It is this. Okay. Next, at theta, sigma 2 is at an angle of 90 degree. Sigma 2 is at an angle of 90 degree. At 90 degree, okay, represent it properly. First, I will draw xy plane. Xy plane. At theta is equal to 0. At theta is equal to 0, I have sigma 1. At theta is equal to 90 degree, I have sigma 2. There are no shear stresses, nothing. This is sigma 1 and sigma 2. Hope you can understand this. You can, if that is sigma 1, that can be sigma 1 acting in the other side, sigma 2 for equilibrium on the other side. This is sigma 1. You can write it properly like this. Need perpendicular lines, you have to write it. Okay. Next, coming to shear stresses. Instead of sigma 1 and sigma 2, you can write sigma p and sigma 2, whatever. So now coming to shear stresses. Shear stresses. Shear stress. As usual, I will indicate xy plane. XY plane. Okay. Now, theta S1 is at an angle of 45 degree. Clockwise theta is positive theta is measured anti-clockwise. So theta S1, I will indicate arbitrarily. This is S1 plane. S1 plane. Similarly, on this side also S1 plane. Perpendicular to it will be S2 plane. S2 plane. Indicate it with a plane like this. S1 and S2. S1 and S2. Okay. On this plane, okay, we have substituted. See, you can see when I substituted. Okay. Now, I want to know the magnitude of this sigma tau, right? Give me a moment. Okay. 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 Now, sigma t is given by, I want to know whether the tau, this sigma t acting in the clockwise, like downward or upward. In order to know the sign, I will substitute sigma t is given by minus sigma x sine 2 theta by 2, sine 2 theta by 2. I will substitute in case of this theta s1, I will substitute the value of theta s1. Theta s1 is equal to 45 degree. Theta s1 is equal to 45 degree, as sigma 2 is equal to minus sigma x by 2. Sigma 2 is equal to minus sigma x by 2. Negative sign indicates clockwise. On the x phase, my sigma t or tau max is acting in clockwise direction. My tau is acting, or sigma t is acting clockwise. See, I have written what I have written. First, I have found out this theta s1. Theta s1 with respect to x plane. There is my given plane. There is with respect to p is at an angle of theta s1 is at an angle of 45 degree. With respect to that 90 degree, my theta s2 will be there. Theta s2 will be there 90 degree. So I have represented theta s1. Now what I have to do, I have to represent the shear stresses on this plane. This is the plane G. Okay, this is the plane G. Now I have to represent the shear stresses. Also, we know that on the planes of shear stresses, where the shear stresses are maximum, these planes are also accompanied with average stresses, sigma average. I need to represent both. I have represented theta s1 at an angle 45 degree. See, when I write, in order to know whether the shear stress is acting like this or like this, I don't know time being. What I will do, I will follow a thumb rule. I will substitute my theta s1 in sigma t. If I get it negative, my sigma t is rotating my s1 phase in clockwise direction. This is clockwise direction. This is my sigma t, which is equal to, you should write sigma, you can write tau or sigma t, which is one and the same, which is equal to sigma x by 2. Also, when you write like this, and the opposite phase, it is like this. On the other phase, it is like this. The other phase, it is like this. Okay, this is about my this one shear stress. what I have written, I have founded out the planes where the principal stresses are maximum. Principal stresses are maximum 0 and 90 degree. I have represented that on plane G. This is the plane. If you take this is a plane G, this is a rectangular box. This is the plane G. Now, on which planes the shear stresses are maximum? Shear stresses are maximum, and the shear stress S1 the plane is at 45 degree, S2 plus 90 degree to that. So then 90 degree, I have written that plane. Now, how to indicate? It is indicated by its normal. S1 plane is at an angle 45 degree. Now on this plane, how to find tau? Tau we got, magnitude of tau we got it as sigma x by 2 and sigma plus sigma x by 2 and minus sigma x by 2. But I don't know whether it's positive or negative. What I will do, I will substitute the value of theta s1 whatever I want. These are the planes on which the shear stresses are maximum. Theta and s1 is equal to 45 degree and theta s2 is equal to 135 degree. These are the planes on which the shear stresses are maximum. But in order to know the direction of shear stresses, I will substitute the values of theta s1 is equal to 45 degree in this expression, sin theta by 2. If I get positive, then my on this s1 plane, the arrow should be positive, pointing in the anti-clockwise direction like this. If I get negative, it should be pointing downwards. That is clockwise rotation. If it is positive, it should be pointing. It should create a counterclockwise rotation. If it is negative, it should create a clockwise rotation. Okay. Now these planes are accompanied with tau, and also we came to know there are normal stresses of magnitude sigma x by 2. On all the faces, there is a shear stress of magnitude sigma x by 2 like this. Sigma x, this is average stress sigma x by 2. Sigma x by 2. Sigma x by 2 and sigma x by 2. Okay. Now these are maximum shear stress planes and maximum shear stress planes. Hope you understood. So what I did, I find it the planes on which the principal stress finds. I found it which are the principal planes and the magnitude of principal stress, and I found the shear stress planes and the magnitude of shear stress, and also maximum shear stress is accompanied with average normal stress, which is in this case is sigma x by 2. Okay, hope you understood this, right? Have you understood this? Have you understood this? Have you understood this? Hello? Have you understood this?
Yes, sir.
Any doubts? No, this is for confirmation. I'm asking you if you understood this. All the procedures remain the same. What you should know. Let me explain once again so that you will not forget. For all the problems, the procedure is same. First, what I will do. First, I will dissolve the forces. I have the sigma x. I will, since for simplicity, I will be representing in terms of force F. When I write force F acting like this, for I will be also getting for equilibrium. I will be getting normal force F of n and tangential force F of t. Okay, I will resolve this force F in along the normal component and the tangential component, and we're getting some components. So summation of force in normal direction should be 0 and tangential direction should be 0. I want the force on this plane G, hence I have resolved into normal and tangential direction. After resolving it, sorry, sorry. After resolving it, I want to find for what on what planes or what angle my this one normal stresses are maximum. I got a normal stresses is of magnitude in terms of sigma x and theta. But on what angle these normal stresses are maximum on what planes? First, what I will do by inspection, since it's a simple problem, by inspection I founded the planes. I find out the planes and then I will substitute these values of planes, whatever the values I got theta 1 and theta 2 to get the normal stresses. First, I will find the values of theta p1 and theta p2, and then I will substitute into sigma normal. Okay, this is first step. Next, I will go to sigma t. I will find t2, theta s1 and theta s2. I will substitute once again into sigma t, and I will be getting tau max or tau minimum. Okay, but always you should remember that the sigma tangential planes are also the maximum shear stress planes are also accompanied with average shear stress. In order to find that, I will substitute the value of theta s1 in sigma normal. That is a normal plane. Whether the shear stress plane is accompanied at this angle theta S1 is equal to 45 degree. Is there any average test we should find out? This is for your clarity. I've written on this plane at theta is equal to 0, theta P1 is equal to 0, theta P2 is equal to 90 degree. There are no tangential stresses. These planes are called principal planes, principal stress planes. Okay, and then I substitute it. I will get sigma n is equal to x by 2, sigma x by 2. I should represent in terms of a sketch without scale. If you there's no need of scale or angle. Theta one is a theta P1 is at an angle 0. On that plane, sigma P1 is acting, sigma P1. Theta P2 is at an angle 90 degree, and sigma 2 is acting on this plane. Okay. Now, this is about principal stress. At theta is for shear stress with respect to, I should always rotate with respect to x-axis. If theta s is minus 45 degree, I would have been rotated in anti-clockwise direction, like clockwise direction like this. Since theta s1 is positive, I rotated it from the x-axis of the reference. I rotated it in the anti-clockwise sense. So theta s1 is equal to 45 degree, 90 degree to it will be theta s2. Okay, theta s1, 90 degree to that will be theta s2. Theta s1 I got, and then in order to find a direction of tau, this sigma t, I cannot write sigma t directly like that. So what I will do is I'll substitute the magnitude. So I'll substitute the value of theta s1 into sigma t. If I get negative, it means to say that my S1 plane is rotated in the clockwise sense. If I get it as negative, it means to say that if I get it as positive, it means to say that my S1 plane is rotated in anti-clockwise sense. Isn't it? My positive is rotation in anti-clockwise. My positive is rotation in anti-clockwise direction. So in order to know the tau, we have substituted this direction of tau, I have substituted it values. After getting that, but these planes are also accompanied with average stress. I need to represent the average stress, which is given by sigma x by 2. Okay, is this clear? Is this clear up to here?
Yes,
Is
sir.
this clear? No, don't feel difficulty. It is quite difficult one time being. It is little difficult for you to understand. But if you understand the conceptually, it's more than sufficient. So there are principal stress planes, maximum shear stress planes. So how you to derive? This is how you have to derive. You take the normal forces is equal to normal forces in normal direction equal to 0, and tangential direction is equal to 0, and then you find the maximum value of principal stresses, and you find the maximum, and you find the planes on which the principal stresses are present, and you find the magnitude of principal stresses. You find the planes on the maximum shear stress plane, and you find the magnitude of shear stresses, and also shear stresses magnitude of these shear stress planes are accompanied with the average stresses. You substitute theta s1 in normal stress, you will get the magnitude of your this one sigma normal average, sigma average you will get. Okay, this is how you have to go it. Okay. Now we have discussed this. I'll give you a same convention. Yeah, well, is it clear? There should be no difficulty. All derivations are same. Let me consolidate and write it. You'll come to know. Okay. Resolve the forces along normal and tangential direction. Second, find the planes of maximum principal stresses theta p1 and theta p2, and substitute theta p1 and theta p2 in sigma n to get sigma 1 and sigma 2. Find the planes of maximum shear stresses theta S1 and theta S2 and substitute theta S1 and theta S2 in sigma T to get sigma T max or minimum or tau max or tau max or tau min. Find the planes of maximum shear stresses theta S1 theta S2. Okay. Okay. To know the direction of sigma T, substitute theta S1 in sigma T. If sigma T is positive, it rotates S1 phase in counterclockwise direction. If sigma T is negative, it rotates S1 phase in clockwise direction. Also, the planes of maximum shear stress is accompanied with normal stresses. Substitute theta S1 or theta S2 in sigma n to find the magnitude of sigma average. Is this clear? Is this clear?
Yes, sir.
Is this clear? These are the 5 points you should remember. First, we'll resolve the forces and we'll find the planes on which this sigma n is maximum. We'll substitute back those values theta p1 and theta p2 to sigma n, and we'll get sigma 1 and sigma 2. Similarly, we'll find sigma theta s1, the planes on which shear stresses are maximum. We will substitute theta s1 and theta s2 values, that is 45 degree and 35 degree, into sigma t, and we will get our tau max or tau minimum. Now, to know the direction of sigma t, we will substitute theta s1 in sigma t. If it is positive, it means to say that it will rotate the s1 phase in counterclockwise direction. If it is negative, it means to say that it will rotate the s1 phase in clockwise direction. As thumb rule. Next, also the planes of maximum stress is accompanied with normal stress. In order to obtain that, I need to substitute theta s1 or theta s2 in sigma n to find sigma average. This is all the analytical part. Okay, the procedure remains the same for all the derivations. All the derivations are the same, all the different cases of loading. Okay, now I will go ahead. The 10 minutes remaining, I think. See, for sign convention, first sign convention, sir, how do you say theta is positive? I will follow a principle called as, I'll follow a principle called as top drop sweep the clock. Another 10 minutes remaining. I'll try to complete. Top drop sweep the clock. Sweep the clock. For example, if theta, if theta, say this is 30 degree, some theta is given, and top drop sweep the clock. If theta is counterclockwise, it is positive. Theta is clockwise, it is negative. Okay, I will explain this. Top drop sweep the clock. It means to say that it has given theta some 30 degree. Whether it is positive or not negative, I don't know. What I will do, I will follow this approach. From the top, from this top, from this is the plane which has given G. G is the plane. From this top, I will drop a line. I will drop a line. Top drop from the top. I will drop a line. This is for example 6 o'clock. Sweep the clock. Sweep the clock towards the hypotenuse. You come like this. Towards the hypotenuse, you go like this. If you're from the vertical, if you're going towards the hypotenuse is in anti-clockwise direction, your theta is positive. Theta is counterclockwise direction. This is counterclockwise direction. Theta is counterclockwise. This is positive. I'll take another three cases. Next, this is the case. Theta. How do you do? From the top, you will drop. Okay. Then you will move towards hypotenuse like this. From vertical to hypotenuse, you are moving in clockwise direction. This is theta is clockwise direction, hence theta is negative. I will take one more case. You can visit Mech movies. Okay. Now in these two phases I have taken, I will take one more thing. I'll take like this. If this is theta, always I should take with respect to vertical. If this is 45, say this is 30 degree, this is 90 degree, this is 60 degree, 60 degree. Similarly, same thing hold goods. Always you should take with respect to vertical. From the top, you should drop a vertical line and you should sweep the clock like this towards the hypotenuse. If your sweeping is in anti-clockwise direction, it is positive. Since the sweeping is in clockwise direction, my theta is equal to minus 60 degree. Clockwise direction is minus 60 degree. Two cases we have discussed. Okay, let us discuss another few cases. This is one case I've discussed. If I have that, I would have been shown. Let me see. Okay, what I can write. Have you understood this top drop sweep the clock? So let me give it in theory, you will come to know. First step is drop a vertical from the top of the plane. Second, sweep the clock towards that vertical, towards the plane that is hypotenuse. This is hypotenuse. Towards the plane. Sweep the clock towards the plane. If sweeping is counterclockwise direction, then theta is positive, or else if it is in clockwise direction, or else clockwise, theta is negative. When you solve the problems, you'll come to know. It is known as top drop sweep the class. You can visit Mech movies. Mech movies, you will understand the sign convention. Mech movies. You just search Mech movies and go to stress transformation. Go to stress transformation, and then you follow and you check yourself the sign convention or your sign convention only. You'll come to know. Top drop sweep the clock. This is the sign convention. From the top, you're dropping a line vertical and you're sweeping the clock. This is 6 p.m. or 6 a.m. You're sweeping the clock. If your sweeping is in clockwise direction, is negative. If your sweeping in as in this case is in anti-clockwise direction, then your theta is positive. Okay, this is a sign convention. When you solve the problem, you'll get used to this. Okay. Any doubts?
No, sir.
Have you understood this? Have you understood this? Have you understood this?
Sir.
Okay. Next class, I will derive the normal and the tangential stress and the principal stresses for biaxial state of stress, shear stresses, and then your plane stress condition. Okay. We'll complete it off, and then I'll go to the analytical part of solving the problem. Now, finally, we'll go solve by using SolidWorks. This more graphical method. Okay. That should be fine. Okay? I'll stop at this point.